Hi, welcome to the first video that discusses the working backwards method for problem solving. In this video, we're going to focus just on those open response types of problems. All right, so how are you going to work backwards? Well, I think it's a little bit self-explanatory just because the method obviously says we're going to be working backwards. But I wanted to give you a few specifics of what that actually means. Okay, so for the first step, I think you should underline the question. That way you are sure you know what you actually are answering. And the other reason is that you're going to be using it to label something. All right, I'll get to that in a moment. I like to use a flow chart to track what happens to the quantity. Okay, so I call it a flow chart because it has an order to it. So I suggest that you make a box, right? And I'm gonna show you this in a moment. And you're going to label that box as the starting amount of whatever it is that that question was talking about. So for example, how much money did you have at the beginning? That would be the starting amount of money, right? It could be a starting amount of eggs. It could be a starting amount of pairs of shoes, right? It's some quantity. You're going to continue to create that flow chart, right, for as many steps that occur in the problem, recognizing that each of those amounts is still representing the same quantity, right? It's still representing the same amount of money, for example, as it changes throughout the problem. So that number can change, but it's still representing, for instance, the amount of money that remains. You're going to know what the last box is in a working backwards problem. And we're going to talk about why some problems are working backwards problems and some are not. But you're going to know what the ending amount is. So you're going to be able to fill in that box. And then you're going to use inverse operations to work backwards through that flow chart. So I think it's a good idea that we talk about some of those inverse operations. Okay, so what does it mean to be inverse? Another way of saying inverse is undo. Some people like to think of it as opposite, and that's a dangerous way to think about inverse in math, because opposite actually means positive versus negative. Right? It typically is talking about the sign of a number, whereas inverse is something that undoes something else. So here's some examples. We could add, right? Adding. The inverse of that would be to subtract, right? If I add 5, I could undo that by subtracting 5. And if I subtract, I could undo that by adding, right? So it's like this pair of operations. We could multiply, right? That's another operation. How would we undo multiplying? We would divide. Now, there are some other operations that you might want to know as well. I don't think we're going to see them in this problem, but I'm just going to jot them down so you get the idea. Squaring is something that we do, right? Or raising to a power. And to undo that, we would take the square root. Right? So just a little bit of an example that this side on the left undoes this side on the right, right? And this side on the right undoes this side on the left. Okay, so I said before that not every problem is going to be solvable using the strategy working backwards. So what will be a good scenario for that? The first thing on that checklist is that the starting amount is unknown, but the ending amount is known, right? That's what really allows you to work backwards. The second thing that you need is that it looks or reads like it can be undone going step by step. In other words, it was explained exactly what happened from the start to the end. Because if those things are unknown, then there isn't really anything that you can undo. So here's an example of an appropriate question that I would use working backwards to solve. A man competing on a game show ran into a losing streak. So first he bet half of his money on one question, then lost it. Then he lost half of his remaining money on another question. Then he lost $300 on another question. Finally, he got a question correct and won $200. At this point, the show ended and he had $1,200 remaining. How much did he have before his losing streak began? So this is very typical working backwards question. It has everything that we talked about. We don't know how much money he started with. We do know how much money he ended with. We also have an account of exactly what happened to the amount of money from the beginning to the end. We're going to try making a flow chart for this one. So remember the steps. We're going to start the flow chart. I'm going to use a box and we're going to label this. This is going to be the start amount of money. That might be pretty obvious. Here's the part that can sometimes get confusing in other questions. I don't think it's going to be confusing here. But as we go through this flow chart, something's going to happen to this amount of money. This box has to represent the amount of money that remains. And each following box is going to also represent the amount of money that remains, right? Because finally we're going to end up with this $1,200. What I'm going to do here with these arrows is represent what happened. So let's do our first step that happened here. First, he bet half of the money on one question and lost it. So, how much money did he actually lose? We're not sure how many dollars, but we know that he lost half of that money, right? I'm not going to put minus 1/2 here. That would be meaning that he lost half of a dollar. What I am going to do is say that half of his money remains. So I'm going to take the amount of money that he started with and multiply that by 1/2. Because half of it remains, half of it is gone. And it's very important that we realize that we're finding the amount that remains. Because if you're finding the amount of money that he lost, that's a different flow chart, right? We want to just track the amount of money that remains. So we'll keep this going. Here's another amount of money that remains. He lost half again. That means half of his money remained. Then he lost $300. Oh, now I can finally put minus a number that I know, right? So notice the big difference here. When you lose a fraction, right, that really is a multiplication problem. When you lose a specific amount or specific quantity, you know what that quantity is, that's a subtraction step, okay? These are both losing, they're both getting smaller, but it's different types of information. We need to use different operations there. He finally gets a question correct. He won 200, so I'm going to put plus 200. And it says at this point, the show ended and he had $1,200 remaining. That is where we know the amount of money remaining at the end, right, is the first part that we actually can fill into one of these boxes. Okay, so now what do we do next? This is where we go backwards. This is the whole backwards part. But remember, it says that we're going to use inverse operations. So I'm going to literally go backwards here. I'm going to draw a backwards arrow. I'm using a different color to distinguish that. Inverse of adding is subtracting. So we're going to do 1,200 minus 200. That's 1,000. The inverse of subtracting is adding. So on this step, the inverse would be to add 300. So 1,000 plus 300 is 1,300. To undo multiplying, we divide. Now dividing by 1/2 makes some people uneasy. I do want to talk about how I'm going to multiply by the reciprocal to undo multiplying. Okay, so make a little note here. I think it's easier. So to undo multiplying by 1/2, I multiply by 2/1. Think about that. Halving and doubling, right? They undo each other. So 2 times 1,300 is 2,600. We're going to do the same thing here. Multiply by the reciprocal, which is really 2. And we get 5,200. So how much did he have? Should have underlined this question. Skip my first step. But really, we used that to label, so we kind of did the right thing here. But to answer this question, we would say $5,200 is how much the man had before this started. All right, let's take a look at another question that also is an appropriate scenario to work backwards. So Ken played golf yesterday and his score was 107. Considering that he normally shoots in the low 80s or the high 70s, this round of golf really frustrated him. He decided to buy a new set of golf clubs. But first, he gave 2/3 of his golf clubs away to his friend Dave. Notice we don't know how many clubs that is. Then he gave 1/5 of the remaining clubs to his friend Gary, and finally gave 3 clubs to his neighbor and was left with his putter, which he decided to keep. So that means we know the ending amount. How many golf clubs did Ken start with before giving them away, right? So we don't know the start amount, we know the ending amount, and we can follow along the events that occurred. So how many clubs did Ken start with, right? This is how many golf clubs he started with. Number of clubs he started with. Now what happens as we go through this flow chart? He's giving them away, but we don't know how many he gave away in the end. We know how many he was left with, right? It's about the remaining, right? We see this word remaining here. He was left with, something remains. So this is the number of clubs that remain. That's very, very important. So let's see what happened on this first arrow. Bought the new clubs. He gave 2/3 of his golf clubs away. If he gave 2/3 away, that means he kept 1/3. That would be the remaining. So I'm going to take the starting amount and I'm going to multiply by 1/3 to figure out how many remain, right? How did I get to this 1/3? Well, 1/3 and 2/3 all together make 1, right? I did 1 minus 2/3. Some people might call this the complement, right? That's a word that we use in probability. It's what you use to get 100% of the stuff. These two numbers together make 100%. Okay, then he gave 1/5 away. If he gave 1/5 away, that means he kept 4/5. So this time I'm gonna multiply by 4/5 to find the number of clubs that remain. Finally, he gave 3 clubs to his neighbor. That's a subtraction because we know how many clubs it was. And he was left with 1 club, the putter. Right, so how many did he decide to keep? That's our signal here that we filled in that box to go backwards. So here we go with inverse operations. I'm going to undo subtracting 3 by adding 3. That brings us to 4. I'm going to undo multiplying with multiplying by the reciprocal, right? That's actually how you divide fractions anyway, by the way. We're just kind of skipping to that part. So I have to take 4 and multiply by 5/4. So that means the 4's cancel, and I'm left with 5. One more thing to undo. We're going to undo multiplying with multiplying by the reciprocal. So 5 times 3 is 15. So how many clubs did he start with? 15 golf clubs. You've seen two examples, right? You know why these are set up for working backwards. Sometimes they're not as straightforward, but you still have some type of ending amount known, right? To set up that ordering to go backwards. But hopefully this is enough to get you started and you're able to solve some problems working backwards. Notice that you could have solved this problem using algebra. I'm going to say that that's not the point of this class. In my problem solving class, right, we are an algebra free zone. I love algebra. My other classes that I teach are algebra. But the point of this is to use some other methods that actually could be easier to use when problems get harder, especially if you're not sure how to do the algebra, right? So that's what I'm asking you to do, is to solve all these problems using this new strategy so that you have another tool in your toolbox. All right, good luck.